Hi, my name is Hitin Atira binti Muhammad Fauzi. My metric number E24B3116. For this slide, I will explain what multiple linear regression is. Multiple linear regression is statistically analysis method that help us understand the relationship between an independent variable and two or more independent variables. In simple terms, we use it to find how different factors like rainfall or temperature can affect the outcome we are studying. For example, vegetation cover. This method is also very useful in making prediction and analysis how strong or weak the relationship. For this case study, we identify the variable based on our objective, which is to analyze what influence vegetation cover. The independent variable or the main outcome we want to predict is vegetation cover measured in a hectare. Meanwhile, the independent variable or the factor that may affect vegetation are first the average monthly rainfall in millimeter and second the average temperature in degree. These two factors are believed to have an impact on how much vegetation grow in the certain area.
Assalamualaikum warahmatullahi wabarakatuh. I want to present question number 3. Intercept minus 39.041 is the value of rainfall and temperature are 0. Then the expected value of vegetation is minus 39.041 HA. Second is rainfall 0.368. Every 1 millimeter increase in rainfall will increase vegetation cover by 0.368 HA. The third is temperature, which is minus 1840. Every 1 degrees increase will decrease vegetation cover by minus 1.840 HA. However, it is not significant based on the p-value. Next is question number 4. R-square 0.899 means that 89.9% of the variation in the dependent variable, vegetation cover, can be explained by the independent variable, which is rainfall and temperature. This indicates that the regression model is very robust and suitable for use in forecasting purpose.
Assalamualaikum warahmatullahi wabarakatuh. I want to present the question number 5, Global Hypothesis Test, Model Significance. The purpose of the test is this test was conducted to determine whether the regression model is useful in explaining the relationship between independent variables, average temperature and monthly rainfall, and then dependent variable, vegetation cover. If the model is statistically significant, it means that the combination of temperature and rainfall explains the variation in vegetation cover. Hypothesis tested. There are two main hypotheses. Null hypothesis, HO, all regression coefficients are equal to 0, B1 equal B2 equal 0. No significant relationship between temperature, rainfall and vegetation cover. And then second alternative hypothesis, H1, at least one coefficient is not equal to 0, B0. A significant relationship exists between at least one independent variable and vegetation cover. That's all. About the test result, we use the ANOVA table SPSS. F value 75.703 and then p value 0.000. This p value is much smaller than standard significance level of 0.05, indicating the result is statistically significant. Interpretation of the result, since the p is bigger from 0.05, we reject the null hypothesis HO. This shows that the regression model is statistically significant overall. at least one independent variable, temperature or rainfall, has a significant effect on vegetation cover. This means the model captures a real and meaningful relationship between climatic factors and vegetation. The conclusion is the regression model is statistically meaningful and reliable, can be used to predict the vegetation cover and demonstrate that temperature and rainfall together to explain the change in vegetation cover. That's all. Thank you.
For this slide, we will look at the result of the individual hypothesis test for the two independent variables in the regression model. The purpose of this test is to determine whether any of the variables can be dropped or need to be retained in the model. The first variable is average monthly rainfall. The p-value for this variable is 0.001, which is less than the significant level of 0.05. Therefore, we reject the null hypothesis and conclude that the variable is significant and should be retained in the model. Next, the second variable is average temperature. The p-value for temperature is 0.671, which is greater than 0.05, so we fail to reject the null hypothesis and conclude that this variable is not significant. Thus, it can be dropped from the model. In conclusion, only one variable, the average monthly rainfall, is retained, while the average temperature can be dropped based on the result of the individual hypothesis test.
And for question 7, we were asked to predict the groundwater recharge rate based on 3 variables: vegetation cover, rainfall, and temperature. We use a multiple linear regression model that we developed using SPSS. The regression equation is recharge rate equal to 0.8317 plus 0.0144 multiply vegetation plus 0.0043 multiply rainfall minus 0.0557559 multiply temperature. Next, we substitute the values into the equation. The vegetation equal to 102, rainfall equal to 535, and temperature equal to 22.5. You can refer to the breakdown of the calculations on the slide. It shows how each value is multiplied with its corresponding coefficients. Then we add all the components together with constants. Also, you can refer to the breakdown of calculation on the slide, and the result is 3.33 mm. Therefore, the predicted groundwater recharge rate is approximately 3.33 millimeters per year under the given condition. That's all, and thank you.
Last but not least, for the conclusion, I personally compile and integrate all the part of analysis, from interpreting the regression model to performing the conclusion, to develop a complete and coherent response for question 8. Based on the input value for vegetation cover, rainfall, and temperature, the predicted groundwater recharge rate is approximately 3.32 mm per year. This result highlights how multiply linear regression can be applied effectively in environmental studies. It produces a meaningful and practical insight for water resources management. Last but not least, for the conclusion, I personally compile and integrate all the part of analysis, from interpreting the regression model to performing the conclusion, to develop a complete and coherent response for question 8. Based on the input value for vegetation cover, rainfall, and temperature, the predicted groundwater recharge rate is approximately 3.32 mm per year. This result highlights how multiply linear regression can be applied effectively in environmental studies. It produces a meaningful and practical insight for water resources